Mrs. Russell was her name. She's, think how old I am. I couldn't be the same. She was old when I was young. She'd be like 97. But anyway, look at us reminiscing about our awful music experiences. We were. I don't know what's happened today. I printed your notes out. That's what's happened. This section is rational functions, which means we get a break from PRZs. We get a break from all that stuff. But we did this in chapter 1. I don't know if you remember this or not, but they're kind of a pain to graph. We had to talk about domain. We had to talk about asymptotes. Remember all that fun stuff? Vertical asymptotes, horizontal asymptotes. Oh, so much fun. Definition is just a polynomial over a polynomial, so that's why they're thrown in this polynomial chapter. But the book says where n of x and d of x are mutually prime. Do you know what that means, mutually prime? It means they're prime to each other, which means it can't be simplified. All right, so mutually prime just means no common factors with each other. So we have to go back to domain. Oh my goodness, it's been so long since we talked about domain. Why don't we talk about domain with polynomial functions? What's the domain of every polynomial function? Yeah, they're those nice smooth curves, and so we don't talk about it because they all have the same domain. That's not very interesting. But rational functions usually don't have a domain of all real numbers because of these x's in the bottom, right? And so you have to say, what can't x be for number 1? Negative 10. So we can say x is not allowed to be negative 10. Because you can't divide by 0. And remember, there's 2 ways to write this. You can write it in set notation, which is where you make the little squiggles. You draw the line, you write x. Right? Remember that? Or you can write it in interval notation. How would I write the interval of every number but negative 10? Colton? Negative 10. Right? So a lot of people like set notation better because they don't like skipping around, but this is everything but negative 10. So it's just kind of making those little intervals. I usually put the u in between it. That's mathematically correct. If you didn't put the u, I wouldn't mark it wrong. Rachel. I mean, Maddie.
Do you have a way that you prefer us to write it, or is either way?
As long as you do the brackets or you do that, I don't care. What's not okay is if you just say x can equal negative 10 and you don't put the brackets around it. That's not set notation, and I would probably take the point off. But as long as you put the brackets around it, I'm fine with it. I like interval notation, but that's just my personal preference. So it's your choice. Especially like on number 2, when the domain is restricted to 2 different things, sometimes this is kind of ridiculous to do. Like, we'll look at it in a minute. This one's really nice because it's factored already, but just be aware that sometimes it's not factored and you might have to factor it yourself. But since it is factored, do you agree that we would say x can't equal negative 2 and x can't equal 6 on that one? But again, set notation's kind of nice because all you do is write that and you put the brackets around it. And so I'm not opposed to doing that. Because think about the interval on this. We'd have to say everything except negative 2 and except 6, which means we're going to have a lot of intervals here if we do that, right? Like if I started this, I would say negative infinity to negative 2, skip negative 2, and where would I stop? 6, and then skip 6, and go to infinity, right? Like that's kind of a pain to do. I'm okay with it though. Okay, it's your choice. Kind of maybe okay with that? This is okay, or this is okay. Like either answer is acceptable. Okay? Domain is important because when we graph these, where our domain is not is an asymptote. And remember, those asymptotes are really important. Okay? When I printed these, I didn't realize how small these graphs would be since I made them 4 on a page. So just, you know, I apologize in advance for this tiny graph on the next page. Look how dark your graph is on the printout, and look how light it is up here. It's the same graph. I just hit print. I'm just so upset why it's doing this, but that's it. I'll just squint my eyes. This is one of our 10 graphs, right? Remember that from chapter 1, our library of functions that we should know? We should know what this looks like. But just to remind you, we have asymptotes on this, right? What's the vertical asymptote on this one? 0, because it's never going to get to 0, because there's 0 in the bottom one. It also has a horizontal asymptote on the x-axis, so y equals 0 is also an asymptote. And do you remember what the shape of it is? Yes? Yeah, I call them L shapes, right? Where it kind of goes up and follows the asymptotes. You can think about if you plug 1 in here, you would get 1. But if you plug 2 in here, you get like 1/2, and then 1/3, and then 1/4, and then 1/5. Keeps getting closer and closer to 0, but never touching it. If you go backwards, if you pick like 1/2, you get 2. 1/3, you get 3. So we kind of just wing it most of the time. Oh, that shouldn't really touch there. Something like that. And if you put negative numbers in, you get the same shape, but it's negative. It reflects over the origin here. Hey, you just learned this today. You're probably sleeping, but... I have Bryce in 3rd hour college algebra, and he normally doesn't sleep in 3rd hour, but today, I'm pretty sure he was. He says he wasn't, but I'm fairly certain that he was. His head was down. Ideally, we could graph these transformations, right? Like if we put a number on the outside, we could move this up or down, left or right. But sometimes these get kind of crazy with the transformations, and you just have to make an XY chart. But that's what we call the parent function. So let's talk about these asymptotes again. When I got to this page yesterday, when I was going through my notes to review what I was teaching you today, and I saw this big whole thing again that I've made you write out once before, and everybody freaks out about it, I just decided I'm just going to print these out, because I gave you this exact same slide in chapter 1, like you have it in your notes somewhere. And remember that this whole thing is just how they write polynomials, where this is the degree of the numerator, this is the degree of the denominator, and they just count down until there's a constant. And they just use all these letters that just kind of freak people out. But we write it like this because the rules for horizontal asymptotes use the degrees, and they use the leading coefficients. And so that's what that's for. But that's why I decided to print it for you. Remember that vertical asymptotes are just exactly where your domain isn't. So at the zeros of the denominator, or you can say set the denominator equal to 0, just like you do for the domain, right? So that's usually pretty easy to do. But the horizontal asymptotes, on their chapter 1 test, there was a question that said list all vertical and horizontal asymptotes. And for the horizontal asymptotes, you have to know these rules. And if you don't know them, you don't get the question right. So if your numerator is less than your denominator degree, so if the numerator degree is smaller than the denominator, it will always be the x-axis, y equals 0. Just like 1 over x, because the numerator has no x, the denominator has 1x. If the numerator degree is equal to the denominator, this is your leading coefficients, which means it could be any number, whatever the leading coefficients are. So like if you had y equals 7x squared over 5x squared, those are the same degree, so your horizontal asymptote would be the line y equals 7/5, which isn't really that pretty to graph, but it would be the asymptote. And if the numerator is bigger than the denominator degree, there is no horizontal asymptote. And we didn't talk about this in chapter 1, but that means there's a slant asymptote, and we are going to talk about that today and graph slant asymptotes. But you have to memorize this, right? When we have a test for chapter 2, which will be next week, you've got to know these rules. So let's just practice doing a few asymptotes, and then we'll practice graphing, slant asymptotes. And that's it. That's not very much, right? Not a lot today. But it's a lot of review from chapter 1. So very big. Final asymptotes. Most people do better with the vertical asymptotes because they know they're just setting the denominator equal to 0. So remember that asymptotes are equations, so you have to write it as x equals a number or y equals a number. But like for number 4, to find the vertical asymptotes, all I'm going to do is set the denominator equal to 0, and you just solve it. In this case, do you agree that we're going to have 2 vertical asymptotes? Plus or minus 3? And again, notice when you solve the equation, you get x equals, so you're done with the vertical asymptote. Horizontal asymptote, there's no work to show, but you got to know the rule. In this case, the numerator has a degree of 1, the denominator has a degree of 2, so the numerator is less than the denominator. What does that mean for my horizontal asymptote? If the numerator is less than the denominator. Right, so we say y equals 0. Horizontal asymptotes are always y equals a number, and it's just y equals 0. There's no work to show. So do number 5 if you haven't already. Do your vertical asymptote, and then look at the degree of the numerator and the degree of the denominator, and write your horizontal asymptote. X equals -1/2, yes? What about the horizontal? The numerator and the denominator have the same degree. They're both x to the first. Remember that it's the leading coefficient, and the big mistake that people make on this is they tell me that it's 1 over 1 because you think it's the first number, right? It's not that. It's the numbers in front of the highest degree. So did you say y equals -5/2? Yes, no, maybe? Questions? Again, we did this in chapter 1. It's been a little bit, but just want to refresh your memory on that. It's important to be able to find your asymptotes because you're going to have to graph. So I'm going to actually switch the order of these graphing ones. We're going to graph number 7 first because it's easier, and then we'll come back and graph number 6 because it's terrible. Since you have them printed out for you, we can just do that, right? So let's do this one first. This one's easier because, one, it's less things in the equation, but also it's easier because there's only one asymptote. And when there's only one asymptote, it's just going to be find the asymptote, and they're going to be those L shapes. You just have to figure out where they are. My bare minimum directions for you when you're graphing a rational function is step 1, start with your asymptotes. So find all your asymptotes. And then step 2, instead of just randomly picking numbers, step 2, pick numbers around your asymptotes. Right? If I had to just give a blank direction on how to make an XY chart for graphing a problem, I would say pick like -1, 0, and 1. But that's not true for these problems because you want to start with your asymptote, pick a number on either side so you can see kind of where those L shapes go. So what is my vertical asymptote on this one? 3 minus x equals 0. X equals 3. Agree with me on that? You do the work, but it's just 3. What about my horizontal asymptote? The numerator has no x, the denominator has an x. So the numerator is less than the denominator, so my horizontal asymptote is y equals 0. Don't be afraid to say the answer. All the cool kids do. So I'm going to make this with dotted lines. I'm going to be fancy here. No, not that. And say y equals 0 is an asymptote, and x equals 3 is an asymptote. What do the asymptotes do? They kind of cut your graph into pieces, and we know it's those L shapes. We just have to figure out where they are. So that's why I say start with your asymptote and pick a number on either side. You can pick a couple numbers if you want, but usually one number on either side kind of gives you an idea of where to start, and then your asymptote gives you the boundaries. That's what's next. And since my asymptote is at 3, I'm going to pick 4. you don't even have to make the chart on this one. You can kind of just do it in your head. But if I plug 4 in there, I get 1 over 3 minus 4, which would be 1 over negative 1. Agree with me on that? So that means at 4, it's at negative 1. And we can pick a few more points if you want, but that's why it's nice to know what these are supposed to look like. They're supposed to be those L shapes. I know it can't go past either one of those, and so it just kind of follows that sort of like that. And I'm pretty lenient on these. I do check that you have the first point right, but then you just kind of make the shape. And oftentimes they're right across here, but sometimes they are right next to it. So I say it's not a bad idea. Pick the point on the other side, which in this case would be 2, and just make sure you know whether it's positive or negative. And it is going to be positive because 3 minus 2 is 1, and 1 over 1, it is going to be that same shape, sort of roughly like that. And that's not bad to graph. All right, the asymptotes actually kind of help you not have to pick a lot of points. Number 6 is awful to graph, so let's do that one, because if we do that one together, you know, in the future when you see an awful one to graph, you'll know it's possible to do. Maybe? Let's go back to this one. What's awful about this one? One thing that's awful is there's just a whole lot of stuff to plug in. Like, I like the last one, because it was just like 1 over a little thing. I could plug those numbers in really easily. This is a big pain, especially for those of you that just really rely on your calculators. Be careful plugging in numbers, especially negative numbers. My advice is do the top and then do the bottom so you don't make a mistake typing stuff in your calculator. What else is rough about this is the asymptotes, right? We got to factor the bottom here, which means we're going to have 2 asymptotes, which means we just have a lot more points to pick. What's that factor into? 3 times 2. Positive 3, negative 2. So I get x equals negative 3 and x equals positive 2 as my vertical asymptotes. We did a worksheet over this in chapter 1. Like, I made you graph like 4 of them. They were awful. What about the horizontal one in this one? Degree of the numerator, degree of the denominator. The numerator is less than the denominator, so it's still going to be y equals 0. Again, start with that on your graph. And again, I know your graph is small. It might be better to just make your own or just squint a lot. I can't see mine, so we're kind of in the same boat. So y equals 0 is still here. Oh, man, that's not really great. That's okay. Negative 3 is roughly here. Positive 2 is about here. What else makes this bad is we now have 3 sections of my graph. So the outside 2 edges are still those L shapes. You just pick like 1 point and see what's happening. But the inside, you actually have to pick a few points. Do you remember what 2 shapes I said pretty much always show up in the middle? Yeah, like an S shape, like a cubic or a parabola. So you have to make sure you pick enough points that you're confident whether it's a parabola or an S shape. Something else I want to point out about the middle here is although the horizontal asymptote goes here, the middle part can cross that line. And I know it kind of goes against what we say about asymptotes, but a horizontal asymptote is more about what happens as x gets really big and really small. So it's more about what happens out here. So I'm just throwing out there that sometimes the middle part does cross that asymptote. It's never going to cross the vertical one, but this is more of a calculus concept that if you take calculus next year, you'll learn all about limits and how awesome they are. And you'll know why I avoid the concept in precalculus. So, but just know that it can cross there. I like to start with the outside edges because it's less work. And I'm just going to pick 1 point because I got a lot of work ahead of me. 1, 2, 3. And again, I'm not a big fan of the calculator on this because I just feel like it's a pain for me to type it all in. I'm okay if you use your calculator, use parentheses, use decimals, I don't care. But I'm just going to do it without a calculator. So you can check my math here. If I plug 3 in the top, I'm going to get 9 plus 4, right? Which is 13 over 9 plus 13 over 6, is that right? Which is like 2 1/6. I'm okay with decimals because you're just graphing it anyway. If you type this in your calculator all at once, you have to put parentheses around the top before you hit divide. If not, your calculator does the order of operations and it's going to divide before it adds. So just be careful typing that in. But 2 1/6, I'm going to say is roughly right there. And because I have a bunch of other work to do, I'm just going to wing it from here. You okay with that? Again, I like to make sure that I graph the other one in the right spot. So I'm going to pick one point on the other side of my vertical asymptote out there, -3. So I'm going to pick -4. And again, I'm just going to plug it in, whether I'm using a calculator or just my good old brain here. That one's going to be -12 plus 4 over 16 minus 4 minus 6, which is 16 minus 10 is 6, or that's -4/3, I think. Like, I can do that faster than typing that in my calculator. So that one is negative. So over here, it's -1 1/3, and again, you just kind of do the best that you can in your decimals. But that part still isn't that bad to do. Not pretty answers, a little more work, but it's still not bad. The bad part is in the middle. We have quite a few points we need to pick, and you got to be confident whether it's a parabola or an S shape. And sometimes you got to pick a few points. 0 is my favorite point to pick. And if I plug 0 in there, it's just, all this is just 0. It's just 4 over -6 or -2/3. So that's like right there. I'm going to pick 1 and see what happens. And that's just going to be what? 7 over 1 plus 1 is 2 minus 6 is -4. Which would be -1 3/4. Again, it could kind of go either way at this point. It could turn and be a parabola. It could go back up. So I have to pick some points over here, which is where it just becomes a pain to do. If I plug -1 in there, I'm going to get 1 over -6. Is that right? 1 minus 1, 0 minus 6. -1/6, so that's really, really close to the x-axis. And for me, like, I was really hoping I could be done at this point, but again, I'm not really sure what's going to happen. I could just wing it either way, but I'm going to pick -2 just to be on the safe side, because I'm a nerd like that, and I don't want to get the wrong answer. And I would get -2 times 3 is -6 plus 4 is -2 over 4 minus 2 is 2. 2 minus 6 is -4. Negative over negative is +1/2. So look what happens. It comes up here across that horizontal asymptote, which means it is going to be that sort of S-shaped graph. And I don't really have a shortcut for you graphing those by hands, unless you have that awesome calculator that you can look at XY chart on. You just have to graph those points. All right? That's about as bad as it can get, but we did it. I did it without a calculator. The only other thing we have to talk about is slant asymptotes, because we didn't talk about in that chapter 1. Everything else up to this point, I'm pretty sure we took almost identical notes already over this in chapter 1. But slant asymptotes are what happens when there's no horizontal asymptote. So when n is bigger than m, when your numerator degree is bigger than your denominator degree, you have no horizontal asymptote, but that means there's a slant asymptote. And so the way that we have to do this is we actually have to divide it, whether you long divide or synthetically divide, kind of up to you, depending on the problem. So when it says find all asymptotes, that means including slant asymptotes. So it's no longer okay to just say there's no horizontal. and ignore the slant asymptote. So number 8 here, step 1, what's the vertical asymptote? X equals 1. What about the horizontal asymptote? The numerator is 2, degree of 2, the denominator is degree of 1. So what's the horizontal asymptote? Numerator is bigger than the denominator. No horizontal asymptote, right? Oh, kids. Right? If the numerator is bigger than the denominator, there's no horizontal asymptote. But you can't just say that and be done. We now know that if the numerator is bigger than the denominator, that means no horizontal, but you have to find the slant asymptote. And the slant asymptote is a slanted line, which means it has slope, has a y-intercept. And the way you're going to find your slant asymptotes is you're going to actually divide this, right? This says all of this divided by this. Long division works every time. Synthetic division only works if it's written like this, right? X plus or minus one number. So on this one, could we synthetically divide this? Yeah. So let's divide it out. And when you're doing a slant asymptote, your answer is everything but the remainder. So you kind of just throw the remainder out. You don't care about the remainder. We're not looking for zeros. What we're looking for is just what's left without the remainder. So I bring my 4 down. 4 times 1 is 4. Negative 2 plus 4 is 2. 2 times 1 is 2. Oh, wait, this is my remainder. It doesn't matter. So we'll write that in our notes so that you remember that. For me, when I do this on paper, I just ignore the remainder. Like, I don't even write anything down so I don't get confused by it. And your asymptote is write what's left using x's again. So if this was x squared, that means this would be the equation y equals 4x plus 2. That is your slant asymptote. It's a slanted line. These are kind of awful to graph sometimes, like they just are weird to graph. But I put a graph, it's actually a bigger graph on your next paper. So if we, like I made it, I think it's on the, you have to flip your page over so if you can separate your papers, you can. But we're going to graph these the same way that we graph the other asymptotes, except for now it's a slanted line, right? So if we graph our vertical asymptote, we're still going to just graph a vertical line down x equals 1. So let's see if I can be fancy here again. X equals 1. Oh, I'm off a little bit. But to graph our slanted line, how do you graph y equals 4x plus 2? Do you remember? It's been a while. Yeah, 2 is the y-intercept, 4 is the, and we're just going to graph it the way we've been graphing it since algebra, except for it's now going to be a dotted line because it's our asymptote. So we have a y-intercept of 2, a slope of 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. It's not actually part of our graph. It's just the asymptote, right? So now we're going to make it a dotted line, which I'm not going to use my fancy line for anymore. And you get this kind of weird shape on the graph when you have a slant asymptote. So graph that and see if you get the same thing. If you have a question about where that's coming from. So just like with the vertical and horizontal, this breaks your graph into pieces. But now they're just kind of weird pieces. They're not nice rectangles. Now your graph's either going to appear here and here, right? Or it's going to appear in these two little skinny sections. And I don't know which one it is until I actually pick a point. So if you pick a point and half of your graph's down here, the other half's going to be up here. Or if one part's over here, the other part's going to be over here. And they're kind of going to look like, I don't know, kind of like slanted parabolas a little bit when you do this. Do you remember doing hyperbolas in Algebra 2 last year where they were like those sideways parabolas? That's kind of this, only the axis is tilted. But let's just pick 0 and see what happens. If I plug in 0 for x, it's either going to appear up here or it's going to appear down here. And if I put 0 into that problem, 1 over negative 1. Do you agree with that? Which means 0, negative 1, I'm going to have a dot right there. And here's the great thing. Although these are kind of weird, the asymptotes tell you what's going to happen. So this side is going to go down and follow that asymptote just like always. But this one's going to kind of follow that slanted line. So it kind of, again, it's kind of like a tilted parabola. This one's going to go and follow that line. I kind of got a little close there. Do you see how that's kind of a parabola sort of tilted on its side? We need to find the other half of this. I know it's going to be up here, but just like before, you have to pick a point. Pick the point right on the other side of your asymptote. So pick, 2? And sometimes it's kind of big. Might be off our graph, but it is going to just be that other half of that. So if I plug 2 in here, I'm going to get 4 times 4 is 16, minus 4 plus 1, all over 2 minus 1. So that's 12 plus 1. I think that's just 13. Ready with me on where I'm getting that? I'm just plugging it in. 1, 2, 3, 4, 5, 10, 11, 12, 13. And again, I'm just following the asymptote. So this one's going to go straight up. This one's going to kind of go out and do that weird thing. If half of it was over here, the other half would be over here. Any vague memories of this? You did this now for 2. It's just been a while. I have another one, but we can stop from there. I do want to point out about long division. What if the bottom of this was divided by x squared minus 1? Can you do synthetic division if the bottom was x squared minus 1? You can only do synthetic division if it's just x to the first power plus or minus 1 number. So just be aware that sometimes you have to do long division when you're doing these problems. Okay? On your test, I'm definitely going to make you find slant asymptotes, but I don't think I make you graph them just because they tend to get really big and crazy. But I think you might have to graph on your homework tonight. Okay? All right, let me, I have your assignment sheet too. So we'll skip this one. I do want to point out, someone asked me about this one earlier. It says a little negative sign out there. So if it was me, I would put that negative x squared minus 1. Like I would rewrite it like that because that negative has to go somewhere. And then you would just do the same thing for your vertical asymptotes. You could synthetically divide to find your slant asymptote. So just know a negative out front, like I would just distribute it through that problem. This is homework 2-6. I don't know if the directions in the book say to graph these 4, but 24, 27, 39, and 43, I want you to graph. So make sure that you write that down. And I have graph paper if you want it, or you can make your own graphs. I don't mind. Let me pass this out real quick, and then I'll get graph paper out if you want it. This is 2-6, yes. And just a little FYI, tomorrow is worksheet day, so I don't really know what that means, but just throw it out there that we have worksheets tomorrow in case you want to